All right, hello everybody. Let me fix my little sub here. Move that over there. Okay, that's better. There we go. Hello. All right. So, yeah, Corsair lights aren't working. Hold on. 1 second. Okay, that's probably won't. Whatever. All right. So, yeah, let's get that open. Some music starting, not Detroit Become Human. Let's do. Oh yeah, there we go. Gonna do the new SimCity. Okay. Move that up there. Okay. Then turn on the. Oh no, it's fine. All right. Let's make sure it's shuffled. So today, before we start on the live stream game, not sure why it's not showing up on this list. Huh. Oh, I know there it is right there. All right. I want to show you guys this game right here. So I'm gonna open up. Oh, okay. This project requires a substance plugin which cannot be found. Would you like to disable and continue? Yeah, I thought I had a substance plugged in. Sure, why not? Oh, probably don't need it. Okay, the following modules are missing or built with a different engine version. Would you like to rebuild them now? Sure. All right, let's rebuild them. Oh, uh-oh. What do we do in this case? Could not be compiled. Try rebuilding from source manually. So, whenever I see that sort of error, let me get this out of here and get this too. I always like to go into the Unreal Engine project directory, go into the save folder, logs, and just pretty much the most recent log. Let's just sort by that and then check what it says. All right, so there's a lot of information here, a lot of log configs, log plugin managers. Scroll down. Here we go, down here. Okay. Warning, incompatible or missing module. Unable to find plugin. Okay. So, there we go. I think we found what the issue is. It's trying to compile, but the substance plugin doesn't exist. So, let's see if I can remove it here. So we check here, substance enable true, set this to false. And interestingly, there's a place for it, huh? Let's check to see if it's here. Okay, so it is right here. Click install, I can install it. But we don't really need it. So, all right, there we go. Let's try reopening it. Okay, seems like that was the issue. So there you go, a little lesson before we start the main live stream. Whenever you sort of reach that sort of error, first thing to do is to check the save folder, and then within the save folder, check the logs. That's the first thing you do. If you can't really find anything there, you could always go back here, right click this, and then just generate Visual Studio project files. I'm not going to do it right now because there's some background tasks going on right now. But what that will do is it'll show a little window. Sometimes might be able to catch an error that prints on that window. But if that doesn't work and that doesn't work, what I'm going to do is open up another file explorer here. Go to app data. Oh, okay. All right, we'll check that shortly. Go to app data percent, app data percent. There we go. Scroll down until you see. Okay, go to local, app data local. Okay, now scroll down until you see Unreal Build Tool, and then there's another log right here that you can also check. But we're gonna check the save folder first because typically it shows up there. All right, MegaJam 22. Full screen. Let's see what the error is now. Incompatible missing modules. Okay. So, yeah, it looks like this is the issue now. So, fatal error cannot open input file. We're going to do close out of that. Next step to do is find the intermediate and the binaries. Yeah. Intermediate and binaries build, it doesn't matter too much. So the intermediate and binaries folder, select those and permanently delete them. Here we go. Alright, now let's retry opening it. Rebuild it, yep. In case you're wondering what's going on right now, you can always check the task manager here. As you can see right here, I'm sorting by CPU, and right at the top is C++ compiler driver. Now I'm not sure if this will actually compile successfully, but there's a little bit of C++ code in this game. I was trying to get some AWS stuff working. This was like made a year ago or so for the Epic Games Mega Jam. Ended up not doing that at all, the AWS stuff anyways. But despite that, it still detects C++ code, so it'll still compile. Alright, I'm gonna take a little bit. Oh, and it still doesn't work. Alright. See what the error is now. Yep, we just keep checking the errors. I might just delete the C++ code, to be honest. Alright, let's see here. So compile C code. Huh, that's weird. Still the same linker error. Alright. Let's do something a little bit different now. So you see the solution file there? Let's open that up. Okay. What is going on? Close out that. Yeah, sure, install that. Why not? Project file cannot be loaded. Okay. So we're gonna close out of that. We're gonna delete the solution file as well. Permanently delete that. Yes, we're gonna right click this. Generate Visual Studio project file. So this is what I was talking about before. Little window there. Got some individual. Yeah, sure, install. Don't worry about that. Oh, huh. My mic isn't being filtered right now. Great. If you listen closely, you can hear my PC fans running up. Darn it, stupid 2 AI noise cancellation not working. Input. Let me try forcing the input. Oh, I don't think I can force the input because I don't see my microphone. Great. I mean, at least it's working in OBS. For once. I mean, last time someone came on and watched the stream and didn't say anything. It'd be much appreciated if you're watching and you don't hear me speaking. Please say something in the chat. Alright. Anyways, so we generated Visual Studio project file successfully. So let's try opening up Visual Studio now. Titles are different. Yeah, okay. Alright, here we go. This looks a little bit better. Okay, so let's just try going up here, build solution. Okay, that worked. Huh. Alright. So let's go back here and let's try opening the project then. I think by now, okay, that's good. Alright, there we go. Okay. So, lesson learned. If your project's not being opened up correctly, then you gotta regenerate the Visual Studio project files by deleting the solution file, deleting the intermediate, and deleting the binaries file. Delete all those, regenerate the files, rebuild the project in Visual Studio. If everything's good, you should be able to run the game up in Unreal Engine. Alright, now that we are getting that started up, we don't really need this right now. And get that and get out of here. We are gonna wait a little bit here. Let me adjust my mic. There's a little scratch on the mic. Hold on, guys. I'm gonna turn myself down. Turn myself up now. Sorry about that. It's actually a fairly old mic at this point. There used to be a little blue LED light up the mic that hasn't worked in like years. Maybe it's just a little simple soldering job to get it working again. I don't know. Alright, so Mega Jam 22 is opening up. As you can see right here, Unreal Engine is stacking the CPU though. Our GPU is perfectly fine right now. There we go. See, still got some little gaps there because of the new my new 5800X 3D GPU, doing all fine. While that opens up, we're actually going to double book it, and we're going to open up the live game project. So we have that ready to go once we are done talking about the game that I'm going to showcase right now. And while we're at it, we're going to open up the Windows key's not working. Alright, that's fine. We're going to open up our note-taking app and our progress management app as well. So that's going to open up in the background. Tonight, with this stream, we're going to be focusing on blueprint coding, what this will involve. So, alright, let's go over here, make a little subcategory. Blueprint code. Alright, so some of the things that we're going to need for blueprint code. We're going to need a player. We're going to need pretty much all this stuff here. So I'll just write down this here. So, I'm going to be working blueprint code just because it's simpler, and also because I don't want to go through how to write C++, and that's going to be a lot more boring. Blueprint's very nice and very helpful and very visual, though it is more limiting compared to C++. Alright. That's nothing, that's just something with one note. Alright, so blueprint, game mode. Oh, oops, that shouldn't be online or blue. There we go, okay. Game mode, game instance, player, state, game state. We have a player, we need a player controller, player pawn. Some of the other stuff that we're probably gonna need, some sort of weapon. Projectile, stuff like that. Maybe some map code. I'm gonna need a main menu, some UI, blueprint code, and just you know, whatever else might come up as we're gonna be building the game. Here we go. Okay, so yeah, that's gonna take a while. Excuse me. All right. So let's get started. So last time we were here, we made our main menu map, just a blank map right here. We went over sort of how to set the project initially. We turned on our Android Vulkan preview because we're going to be making this game as a mobile game. Next step we're going to make another folder here. We're going to name it Blueprints. There we go. Open that up. We're going to do the categorize it a bit. So we're going to have a player folder. All right. We're going to have core folder. So this will be all the central stuff like the game mode and the game state and all that stuff. That's pretty much universal throughout the game. We'll have save games. I'll go over probably in the later stream what save games are, but they're pretty much going to be a way to transfer data as we load different levels, or if we need to save anything per player. That's how we're going to be doing it. And then do a UI folder. This is where we're going to store all the Blueprint widgets. And then last, we're going to do map underscore assets. So one thing that's important in general, even if you're not making a game, is to make sure you have a consistent naming convention. So just right there, I just made a quick little decision to make our naming convention be that any sort of folder paths use underscores and all lowercase, as you can see, excluding of course the like Unreal Engine stuff. There is a, did I link? No, I don't think I've linked it. There is an official Unreal Engine. Oh boy, let's pause that. Okay. There's an official Unreal Engine documentation. Let's see here. Format? Is this it? No, that's where is it? Unreal Engine, not documentation format. Code style? That should be it. Coding standard, there we go. Alright, so there is an official Unreal Engine coding standard that you can follow here. Something interesting things, I read this last week or so for laser tag specifically, is that constant correctness, comments, guidelines for outside commented code, useful codes, don't write bad common code. So that's just like all typical software practice stuff. But naming conventions up here. This is kind of interesting. No, not these naming conventions. Examples, portable C++ code. Somewhere it says that you shouldn't use like somewhat offensive language in naming standards. But I'm not seeing where it said that. Does it say on here? Okay, maybe not on this document. Whatever. I'm just gonna go link the. Actually, hold on. This is Unreal Engine 4, by the way. In case you're wondering how to navigate the documentation, you can make sure that you're on the latest version or whatever the version you're using here. Yes, here it is. So word list, blacklist, whitelist. Okay, so here we go. Inclusive word choice. So they added a little section here. I thought it was kind of interesting. So having like different alternatives for previously commonly used terms, and having like different alternatives for the terms. But if you want to follow this coding standard, then by all means you can. I'm going to link this on the stream chat in case you're wondering. There you go. It's going to show up in Discord. Yeah, there it is. All right. But this is very much allowed for C++, but it can also be utilized in blueprints and like naming conventions and whatnot. So the naming convention that I'm going to be using is file paths, folders, use underscores in all lowercase, except for when it's an abbreviation like UI. Live stream fair. Screw restream. So what? All right. And then when it comes to, let's see here, maps. So we're gonna rename this. Actually, we're gonna make our objects and class names be uppercase and camel case. So camel case is simply where you combine multiple words into one, and then you uppercase the first letter of each individual word. So we're gonna make that be the perform a case unrenamed blah, 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 as not support. Okay, don't worry about that. Yeah, okay, that's actually one of the disadvantages with SVN is you can't rename and change the case of files only. So we can do like instead main menu map underscore, just as like a temporary name. Excuse me. So there we go. We're gonna go submit content. There we go. It's gonna remove that and then add that. Just make this temp. Wait for that. There we go. Submitted. Remove that underscore and an asset already exists. All right. So let's go check that. This, by the way, is still loading. So let's go into live game here. Content. Maps. And then as you can see, we have this extra main menu map. We're just going to delete that. Go back in. We're going to ignore that for now. Get out of here. Okay. Alright, there we go. Let's retry that now. Okay, that's fine. We're going to go back out. Right click. Okay, it's not working. Cancel. Submit content. Huh, okay. I'm gonna just rename this, I guess, right from here. There we go. Go back and forth. Failed to open file. Okay, let's just kind of screw this up. Close out the project and reopen it. So, small tip there. Don't mess with files inside the content folder from within outside of Unreal Engine, because otherwise you're gonna screw up with stuff like that. Anyways, while that opens up the background, we got this opened up now. We got this loading now. It's missing a lot of assets. Missing project settings. There's some 6 required for 99. Okay. Windows. Some 6. Restart now. Okay, so it's, we're gonna look at that a little bit later. Okay, here we go. Main menu map. There's a question mark now because we sort of did some confusing stuff with SVN. That's fine though. We're just gonna right click version control. We're gonna actually go out maps, open up Tortoise SVN commit. There we go. Just check all these and revert temp, main is now main capital N. Alright, there we go. And there we go. Alright, so now go back and forth. It should refresh. There's some problems with asset action utility blueprints. That's weird. NOS is checking. Restart again. Okay, don't worry about that. Alright, so next up, while that goes on, let's start with, let's see here, maps. We're going to make another map. We're going to make just, you know, the root folder for now. We're going to call it test map with a capital T. Shoot, we're going to delete that actually. And then recreate it. Test map. There we go. Alright, there we go. Save the selected. Okay, here we go. So we're going to submit content. There we go. Add test map. Not sure why main menu app isn't being added. Oh no, okay, it's fine. There just weren't any changes. Okay. So there we go. We're in our test map here right now. Right up there, test map. So first thing we're going to do is we need to add some lighting. So there are different types of lights. Which one do you add? So the first one that you should always start with is the skylight. This one is your global illumination. So if I add, let's say, grab a cube over here, for example, or sphere, you don't see anything right now because this light actually computes the inaccurate light model based off of the scene. So we're gonna add, so we could either add this called sky atmosphere. If we add this, tag as the sky using the sky atmosphere nodes, visualize the atmosphere. So we can't really use sky atmosphere on mobile, so we have what is known as the okay, it doesn't exist anymore. Fog, is that gonna work? Alright, whatever. Let's just try sky atmosphere, and then sky atmosphere works with the direction light. There we go. Now we can see our little sphere. We can also see the rest of the sky. We can also see, that's kind of weird. Huh. So this warning here, we're not actually gonna worry about that. We're gonna keep the skylight though, because we're working on mobile and we're working with a top-down style game. So if we go to our plan here, as you can see, it's like some top-down sort of game. So what we're going to do instead is click on the skylight, and so if you have a cube map, you could use that as the sort of light, but intensity scale, let's see here, what settings do we got? Cloud AO, a lot of different settings. Let me try turn up the intensity. Is that gonna work? That's not gonna work, because again, we don't have any lights anywhere in this scene. So what I'm going to do next is add a post-process volume. This is just a little sort of shortcut way that I'm going to do it. There's other ways that you're going to do it. That you can do. What I'm going to be doing is just pretty much setting up the post-process settings. I think the easiest way to do it for like a per map basis is adding the post-process volume directly in and then setting infinite extent. So this should allow me to change global illumination. Indirect lighting color, blah, 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 blah. The show flag global illumination must be can't change that. Okay. We won't worry about that then. Let's check back on the project settings real quick. Go to rendering. Okay, so alright, yeah, this all gets set by default because we're using forward shading. We also support Howard tracing, why not? Sure, why not? No, we're not going to support Howard tracing. Restart later. No need for hardware ray tracing. Alright, so there was some setting that is inaccessible in forward shading. Anyways, so alright, we have our skylight, so this will create, once we have objects in, that will create sort of a back shadow light and stuff like that. We're going to add our directional light now. So it would be an overhead light, so now we can see the object there. If I say duplicate the object, you should be able to see the light. Huh, it's kind of weird. It's no shadow. And no indirect light. Alright, so maybe real-time capture might help out. Maybe changing that. Okay, that's not doing anything. Alright. Ah, maybe this is why. Light needs to be rebuilt. That's because we are working with static lights. So, or stationary, rather. Stationary is partially baked, not fully baked. If we want this light to be moving as the game goes on, then we want it to be movable. If that light is movable, then we also want this light to be movable as well. So making the lights movable, let's just change them right now. Should make everything much more dynamic, although you can't see it right now because you don't got much. We do have right up there preparing shaders 136. We also have compiling shaders 2000 in the background. So now this is fully real-time lighting. Ah, here we go. If you just wait a little bit, let's see what else there is. So this is the details pane, by the way. I don't think I've talked about this yet. It pretty much gives all the basic settings that you need for your object, or pretty much any setting really. What I'm looking for now is shadow. So let's see here, shadow and dark only. So cast shadows on by default, huh? I'm not sure why it's not showing a shadow. Yeah, there's no shadow there. Oh, there's shadows here. Cast shadows on, huh? Alright, so let's go back to stationary for these. I'm going to delete those because we don't really need spheres right now. What I'm going to start with is I'm going to switch actually over to the modeling mode. We're going to just make a basic little testing area. So click on the box. Now, where are we going to put this in the level? I'm going to actually click this little button up here. So this is going to give us a different perspectives on base level, just to sort of help out with laying out where we're going to position the object. Also, this is new. You can now manually specify where exactly to put it. That's really helpful. Alright, so where we want is 0, 0, 0. We're going to actually move it down. There you go. And then let's see here. This is our top view, so let's go give it a little bit of depth and height. We're going to give it a little bit more. There we go. Alright. Material. So we'll just keep that by default for now because we don't have any materials set up right now. Alright, there you go. And then down here, new asset folder, AutoGen folder, world relative. So let's go out back into the content folder. We're going to make another folder. We're going to call this meshes. Go into here. Alright, now current folder right there. Alright, there we go. Click the little settings here. Let's go to modeling tools editor. So we'll open up this right here. Check the, okay, not those, never mind. Modeling tools project. Here we go. So some of the settings that I suggest you probably change. Just keep the default as that. So current browser asset path if available. Sure. All right. Auto generated but do not auto save. So let's change that to interactive prompt to save. If you keep it to this one, and then your engine crashes, all the static meshes that you've done, all that work that you've done, isn't going to be saved. So I like it to here. You can also make it this if you want, but I think the interactive prompt is probably the best. So we'll see what this does when I click accept. There you go. It comes up with a little prompt, and then you can rename it. So let's do test map underscore floor. So this naming convention, we're gonna have like another object here, like the test map, and then underscore whatever it is. So like the floor, if there's like a specific wall or something, then test map underscore whatever that is. Maybe the player has another object like a sub object or something, then we're going to do like default player underscore that. So anything that goes directly with an object, we're going to have naming convention have another underscore, and then there's a random string of characters afterwards. You can keep those if you want. I'm going to delete them, and then of course SVN decides it's going to auto update right now. Yep, thank you. Okay, there we go. All right, and there we go. Now our test little floor area is ready to go. One other thing we're going to do, we're going to open this up and enable nanite support. Actually, it doesn't matter for this. We're not going to bother with nanite. Not yet, at least. But that's how you enable nanite for pretty much any model. You click accept, and then it just generates the nanite meshes. All right, and there we go. Our game is about done. So if I just click play, I just got a spectator pawn. So let's go to world settings here. Game mode override none. So it's using our default settings. So let's go to the project maps and modes. Game mode base is the default. So we need to change that. We need something else. If we go out back into the content folder and go into the core here, blueprint/core, we're going to make our overall game mode. So call this main game mode. There we go. And then if we open this up, as you can see, main game mode inherits from game mode base. So this will be the game mode that we program in. We're not going to be programming into it yet, but just a little future preview of what there is. If we go to event, here we go. So some of the stuff that we're going to be looking at is like on post login, on logout, change name, maybe change name. Init start spot, that's going to be an important one. Handle starting new player, stuff like that. So we're going to be implementing those once we start implementing multiplayer. Okay, so save button, top left corner, you just click save. Also, I like to go into here, click these little three dots, save and compile. Set it to on success only. It's just a little time saver. Alright, and then we're not quite gonna do anything with that yet. Not sure I made that really small. Let's go make the rest of our remaining classes. So we need a player controller, so same thing, main player controller, and then usually that's the only player controller that you need. Might need another different type for like a different platform or something, but we'll make another one as needed. Alright, next up, character. We're not going to make the character in this folder, so we're going to move on to the next one. What other common types do we have? So the actor. Everything in the map, everything in the level is an actor. Actor can be placed in a world. Actor has position, translation, and rotation, and that's pretty much basically it. There's also some tick code as well. So the actor is like the bare bones of what you put inside the level. Alright. Pawn is a controllable actor. character is a specific type of pawn that has some special stuff. We're not going to be using the character, we're going to be using the pawn so that we can implement our own movement more directly. And then player controller and player big, game mode base, we already implemented those. Actor component is something that can be attached onto an actor as like a component that like describes something, for instance. So I can make some of the components that I've had like a draggable component, for instance. So I would attach this onto an object that has physics enabled, or the component would enable physics, and then the component contains a series of functions that let the object get dragged around. So that's something that I did in Cat Smash, which we looked at the start of the live stream last week. And the scene component is similar to the actor component, but it also has a transform, or more properly a scene transform. So that's like how an actor has a position, rotation, and scale. The scene component has the same thing. So the scene component, you can add that, and then just a point somewhere on the actor. So we're going to click all classes here. There we go. So object, that's just like basic C++ object. That's it. All right. What else we got? We got some, if you scroll down here, so eventually we're going to see an instance class. I'm not sure exactly where it is. Game instance, there it is. So that's the, like, what starts up in our engine. We set the game instance. We looked at that last week. But what I need now is state. Here we go. So just go with the game state. The game state base is the older one. This one behaves like a multiplayer match-based game, so we want this one, game state. Main game state. There we go. And then one more, and then we're going to save everything. So go back here, player state. There we go. Select that. Main player state. There we go. Alright, so now go down here. Let's click that button right there. Save selected. There we go. Test map. Okay, yeah, we had some changes in the test map, so we're going to check them out. There we go. And now we have all these green pluses indicating that they've been added to version control. If we go back into the maps, we have a little checkbox indicating that there was a change. And then we can submit. So I'm going to go do a submit right now. Make core classes basic test map. There we go. All right. And submit. Anyways, and then while that goes on, here we go. This looks much better. Except what's going on with those graphics? What the heck? Looks kind of funky. There we go. Okay, that's better. All right, so still preparing a few shaders here, but I just want to show you guys Cat Smash. No, not Cat Smash. Fishing Ducks. That's what this game is. So Fishing Ducks is an entry that I did with my sister who does animation in last year's Epic Games Mega Jam. So the whole point of the game is you play as either a duck or a fish, and your parents sort of play a game of tag where you collect items that will spawn throughout the map. So there's these little these objects here, these collectible spawners, which will spawn them in the middle of the air, quite literally. Once all this work gets done, then we'll show off a little demo. But in the meantime, let's show off, I guess, some of the player code. So a little bit more in here than what we currently have. So what I have, we have the two different pawns, pawns that players can play as, so either the fish or the duck. So we actually have this base pawn class that both the fish and the duck inherit all of. So I'm opening up the base pawn right now. Here we go. Some of the stuff that's in the base pawn, we have a pausing function so that you can get to like the main menu and whatnot. the way that that sort of works. We're going to be making a main menu in our game, but what this is just adds something to the player UI, and because it's multiplayer, we can't really pause, so I don't have to worry too much about that. Alright, what else we got here? So the event possessed is the sort of startup script that runs on the server. As you can see, this little server icon right there. What this branch does is, this is actually incorrect, I just noticed. This creates the main game UI, which is what the player pretty much sees on their screen, but because it's running on the server, it's going to throw a warning or an error. But also then there's event begin play, which runs on any replicated machine, pretty much. So it will create the UI anyways. What else we got down here? Some UI stuff. So creating or destroying the different UIs. So like there's a start pre-game UI, post-game UI, and then the main game UI. Water to air is a function that plays some sound when, say, a duck goes into the water or out of the water, or a fish as well. Wants to play that same sort of sound, so it shares that same class. Event tick is a very important function that we're going to be talking about soon. It loops over every single frame. So what this does specifically is it just counts a timer here. So what this does is it creates a countdown timer on like the last, say, 10 seconds of the game. There's different ways of doing that. I could have made a timeline as well, but sort of working on a rushed timeline, I didn't really think of that. So there we go. That's the base Pong class. I'm not sure why I just say that. Doesn't matter now. So let's look at the fish class here. So we also have some AI code here as well. So my first time working with the Unreal Engine AI system anyways. We're going to be working on that definitely in this game. So some of the stuff in here, there we go, a lot of blueprint code. Alright, so here's that event tick again. A lot more there. So the sequence here executes a series of pins in order. It's good for if you want simultaneous actions, if you want to be able to execute multiple things within one event tick, and you want it to be nice, relatively organized rather than having a long chain of objects or functions to do. Oops, I just pressed this button. This button speeds up my mouse. Okay. Anyway, so some of the stuff that this does. There's a fish animation. This just makes sure that the fish animation is the same. This complicated function right here, check in water, does some stuff with rewarding points if the fish jumps out of the water, and there's some points rewarded. It also checks to see if the fish can move, and also enables a ragdoll mode for the fish. There's a multiplier function for points. There's a water transition, that's right. So a little water effect, and then some updating. This is intended to be replicatable for all, so intended to be replicated to the server mainly, and replicated down to the clients. So yeah, a lot of different code. This isn't entirely correct though. The multiplayer, nah, I didn't really quite get that necessarily tested in time. So it's sort of in an incomplete state. So let's see here, main menu map. Let's start from here. So main menu map is an exact copy of the main map that I had open by default. Right here. One second. Okay, there's some water not showing up. Center of lake, no, not that. Let me check here real quick, sorry guys. Blueprints. There's the collectibles. I was talking about that before. Fortunately, it's not there. We can check geometry. Lake top. Here we go. Okay, so this lake top isn't showing. Actually, no, it's there. You can see. You can just barely see it. There you go. Okay. Player collision. There you go. Okay, lake mat isn't doing what it's supposed to be doing. Let's just click play actually. Yeah, no, it's not. Why isn't it doing it? What it's supposed to be doing is okay. Let's stop that. There's some loud music in the game. So what it's supposed to be doing is playing a little water effect. But checking here, it doesn't look like. Huh? I want actually. Let me close out of this. No. Close out of that. Okay. Go back to this. Ah, it wasn't updated. Or maybe it was. Yeah, let's just play build here. I don't have a build. Great. No, it's right here. Okay. This should be a better work. Oh my god, get out of here, AVG. So annoying. Alright. There we go. Okay, so fishing ducks. Here we go. This is what it's supposed to look like. You see there's a nice, very nice little water effect right on the top there. So, you know, I click play. Yeah, that's it. Yeah, I'll make a virus for my computer to run intentionally for our game jam. Here we go, fishing ducks. Here's a top-down view, so you can either start on the bottom or the top. There's some little water splashing effects there. Click play. There we go. Let me run the file. Probably should switch antivirus. AVG's not really working out for me. Okay, here we go. Finally. So the game will automatically start when everybody clicks ready. I'm going to prefer the fish because I think the fish is more interesting. Here's a little thing for the controls. Click ready. There we go. Now we're going to play a little fish here. You can press W to go forward and it makes the camera zoom out a little bit. If you hold down left click, you go faster, but then you run out of sort of stamina. There you go, collecting a little bit collectible there. And then you slow back down. And then you can go out of the water and get some points. There we go. Nice, smooth game. It actually runs really nice on my high-powered computer. The faster you go, I think there's a bigger multiplier or something. Yeah, this is fishing ducks. You can go down here and some little floppiness going on and collect some stuff. The ducks are in the lead now. There we go. Ooh, yeah. Alright. Let me quit out of here and then we'll go play as the ducks now. I'll just sort of show that off. So for duck. There you go. Oh great, oh no, the duck animation is working, it's just really slow. Okay, so the left click for the duck makes it dive. And go fly up in the air. The majestic flight of the duck. As you can see, the AI it works good enough. I don't think it works that well. Oh boy, the camera's a bit wonky on the top. There's a little ceiling there to prevent you from flying up too high. And then you can go for fish. So if I dive down in the water, collect some collectibles down here. They are a little bit of a multiplier when you're down in the water. So you can also just dive directly. And the UI bar on the right there is now broken. That's great. So I can get a duck. I mean, a fish. Let's see here. Here we go. There's also some rather poor sound design in this. Oh look, there's a duck that's stuck for some reason. Let's see here. There we go. Let's see if we can get a fish. Ow. Let's try again. So the higher you go, the more deep you can go down. Oh, that's why the UI... Okay, never mind. About the whole UI stuck thing. Here we go, and then we win, yay! A little point summary, your score, and stuff like that. Yeah, so that's fishing ducks there. Alright. Just wanted to show that off a little bit. It's a sort of less stable multiplayer. But we're back here now. So let's, here we go, we got those set up. So now we can go to game mode override and then set this to our main game mode right there. And then if we go to selected game mode, we can actually change all these options. But we're not going to do that. We're actually going to set it directly in the main game mode. But we're not going to actually start with that. So game session. The game session, session interface can go browse with this when it needs to active. This game session exists on the server. So the game session, I guess, was something that I didn't really mention last time. So the game session is not too important that you need to modify or anything like that, but pretty much you join a session, you leave a session. Sessions are essentially like game servers or game matches or whatever you want to call them. What we're going to do is set all this stuff to the custom classes that we set up. And then we'll make a default pawn right now, actually. So click compile, there we go. Checkout selected, there we go. And it's saved because we had save and compile on success only, and it was successful. So now go back out, go to the player. I'm gonna make a pawn. Call it have caps lock on. Base player. There we go. So now save all. There we go. Check out the selected. Then go back to here, default pawn. Change this to base player. Compile that. Alright. So now, if we got the base player, nothing shows up except for that little icon, but that's still like a placeholder icon. So for testing, we're going to add a simple sphere. There we go. There's our sphere. I'm going to click compile. And then we need something for the player to be able to view our sphere, or be able to view the player, or view at all. So we're also going to add a camera here. Let's call it camera. Call that sphere. We're going to make this sphere the default scene root. There we go. So now this is the center point pretty much of our player character. If we move the player character around, we move the sphere around. We might change the sphere out later for a different stack mesh, but we're not going to worry too much about that for now. What I'm going to do is I'm going to position our camera so that is at an ideal position. So something, say there. Click compile. Let's see what that looks like. So if we go out here, we have our player that we add into the level. We can see that right here. So we're going to pin it if we want to. I'm not going to pin it though. Now if I click play, it auto spawned. Okay. So why it did that was, it's because we were using the current camera location. Now if I go back to here, I can make it auto possess the player. So possession is when a player controller takes over a pawn. So now we are in control of this pawn. Of course right now we haven't set up any inputs, so nothing really happens. What I want to do is I want to angle that camera up just a little bit and maybe move it back. There we go. I was just adjusting it on secondary display. You saw it moving there. You just drag the arrows here. So X is red, Y is green, and Z is blue, like RGB. You can drag them around the level to position stuff and whatnot. Alright. There we go. And then we're going to place the sphere on our little ground here. So I'm going to go into this view. Zoom in here. There we go. Now it's on the ground. Alright. Oops. Click the full screen button back. There we go. Okay. So one thing I want to check out actually. Let's see what orthographic view looks like. So over here, I'm going to change this to orthographic. There we go. Why is it wireframe? Okay, there we go. That looks correct. So this is the orthographic view, pretty much. And my phone is overheating. Great. Hold on, guys. I'm going to take the case off of my phone to cool down. There we go. Okay. The phone turned off. Oh, no, the phone just shut off. Great. Great. I really nice having old phones. Alright, don't worry about that. Okay, we change it back to perspective. Oh, there we go. Compile. Okay, now we got that. Let's set up our input. So we're gonna go project settings, go down to input. We're gonna be working, actually, no, we're not gonna be doing that. We're gonna be going back out to blueprints. We're gonna be going new folder, inputs. We're gonna be working with the enhanced input system. So to do that, I created the input folder. I'm gonna go to input. We're gonna create first off, an input mapping context. So this will be a collection of our key mapping. So I'll make this, I guess, main input mapping. There we go. Now if I go back to our project settings, I find enhanced input right here. Or default mapping context, I can click add and then expand this. I should be able to add, there we go, main input mapping right there. And just set the priority to default. So we're gonna, if we had different, yeah, sure, we're not. Okay, so we're gonna add another one actually, because I'm gonna show you why. This one's gonna be test input mapping. Because remember, this is, why is the camera open on my phone? Okay, remember, we're gonna be making this game for mobile, Android. So the idea is going to be we're going to have two different separate input mappings. One's going to be for when we're testing on keyboard, mouse, or maybe controller if you prefer that. You could do that as well. And then the other one is going to be when we are testing on for our phone, or like standard controls on our phone. We could also set up different style controls as well. Okay. Alright, I was gonna, hold on 1 second. There we go. Okay. So, yeah, we're gonna have two different input mapping contexts. So, let's open up our test one first. So, we'll just set up the keyboard and mouse input. So, we're gonna add a mapping right here. Alright. And this list is empty. Huh. Interesting. But we can just add one right here. So let's select key values. So let's have like a forward, right? So, oh boy, lots and lots of stuff here. we're not quite there yet. So we're gonna delete that. Next up, we're gonna go back to here, new folder, mappings. Now, just a word of advice. I don't exactly think the input stuff is blueprints, but it's, I'd say still acceptable putting into this folder. Oh boy, sorry. My eyes are a bit watery right now. Allergies or something. Alright, there we go. So mappings here. So we're gonna go input. Here we go. Input action. So gonna go player underscore forward. There we go. So that's our input action. So now we have an action description. So that's an action description. Moves player up the screen. There we go. Okay. All right. So some of the stuff here: consume input. So show this action, swallow any inputs, bound. So pretty much consume input just makes the action the top priority action. When it is set up in the blueprints, it will run the event actions for the specified input before running anything else. So, sorry. Usually, just keeping that on would work well. If you're doing some more complicated multi-input stuff, maybe turning that off might work. Trigger when paused. This is pretty self-explanatory. When the game's paused, it should still trigger. We're gonna keep that off because we don't want the player to move around while paused. Reserve all mappings. So what does this exactly do? Actions mapping are not intended to do. Use them as explicitly. May remember that. Okay, we'll just keep that off for now. So value type digital bool. So let's actually set it to an axis. All right, I forgot about this. This is a bit different than the old system. So player forward, we're actually going to rename this. Player movement. All right, there we go. And then we'll set it to an axis 3D. Just in case we ever want to, have some sort of up-down movement, we could. But that's not going to be our priority. So axis 3D, pretty much what it's going to be. So you have, say, your y-axis here, and then your x-axis here. So the y-axis is going to be moving up and down. X-axis is going to be moving left and right relative to the screen. All right, triggers. What are triggers? Trigger qualifiers. Any trigger qualifier exists if the action will not trigger on this. So let's just see what this is exactly. So trigger actors or qualifiers are the conditions for playing the input. So you can look at the description here. Triggers fire once input has remained for a held amount of time. Triggers fire only when the input exceeds the actuation threshold. So I don't think we need necessarily any triggers right now. Modifiers. What are modifiers? And modifiers just modify the type of input. So for instance, if I might want to do sizzle for keyboard and mouse, but do all right. I'm just looking at this stuff. Okay. Here we go. So I think that's all good for now. There cannot be no input. Okay. Delete that. Sorry about that. There. Okay, that's fine. Okay, so back to here. We're gonna go add our mapping now. Player movement mapping. There we go. Let's go add a W key. So, slight problem though. This is a vector input, right? Yeah, we only have W. W is the key. W is only a binary. So if we had, say, a gamepad, left, right, stick, or whatnot, we could do that. So in fact, I'll do that right now. Go with gamepad. Let's do right thumbstick 2D axis. Okay, but again, this is a 2D vector, not a 3D one, and yet our input is a 3D vector. So let's go to the modifiers. Let's see here. Which one do I need? For W, I think I need a swizzle, if I believe correctly. Okay, maybe not. What? Hold on. Useful to map a 1D input into the y-axis of a 2D action. So for W, we're going to be doing the y-axis, right? Let's add another one. S. So this one is going to be going backwards now. So we're going to have two modifiers. The first one is going to be the swizzle again. And then set that to Y. And then the next one is going to be negate. So we're going to negate only the Y. There we go. And then we're just going to do some nice organization. We're going to move this up there. All right, there we go. One thing here that I'm going to add for modifier is I'm going to add another swizzle input axis value. We're going to set it to... Oh no, that's just reorders them. I'm looking for X, Y, Z, but there's no X, Y, Z. There's an X, Z, Y. Okay, so I assume shouldn't need to change that. We'll test out on the controller. Oh boy, I need to find my controller. Yeah, I don't have it here right now. Probably in the other room. Alright, so here we go. Add in then our A key and D key. Move those up there. There we go. Move A above D. There we go. Okay, trigger. So same thing again. I'm gonna go swizzle the input axis values, but this time we want this to be on the x-axis. So we're gonna do X, Z, Y, although we don't necessarily need that actually. We're gonna keep it anyways, just for good sake. So then with the A, that's gonna be negative Y direction, so Y is to the right. So we want to negate it. I just added 2 items. So negate right there. A, and then the D one, we use the swizzle again, just like what we did before. Alright. There we go, X, Z, Y. Okay. So there we go. We have basic player underscore movement. Click save, save selected. Here we go. And then let's go back to our project settings. We want to make sure that our input mapping context is set to our own. So there we go. Main input mapping. We're going to add our testing one as well, even though it's currently empty. We're going to set the priority to this one to 1, just to make that one a more prominent one. Alright, there we go. Here's some platform settings, input data. Alright, delete that. I'm gonna worry about that later. So there we go. Now if I click play, nothing happens still. That's because we need to code in what happens when the movement occurs. So go back to our base player pawn here. So we're going to go to the event graph right here. So as you can see, there are some events right here. So the events act sort of as functions, but they have special broadcasting, special binding abilities, and they are also essential for replication in blueprints. So we're going to add an event. So player underscore movement right there. Enhance input action player underscore movement. So now we have all sorts of different stuff going on. So we want the player to be moving while the input is ongoing. So we're going to drag out of that. I'm not going to do that actually quite yet. I'm going to go to sphere here. Actually, no, wait, hold on. Actually, let's do this correctly. So let's add a component here. So you remember how I mentioned the actor components before? Let's see it here. Movement. Floating pawn movement. This will help us. So the floating pawn movement, all it does is it just moves, it's going to move our pawn in nice, simple directions. So if I do an add input, add movement input right there. So we'll go add this, and then ongoing, we add in our movement input with the action value. Let's see here, what else do we got? Okay. So I'm assuming that this value is scaled depending on how far the controller is being moved. So that should ideally now move our pawn. It does not. Okay. So let's look at blueprint debugging real quick. Right here, we have our project running. As you can see, we can stop the simulation right now if we wanted to. We have the function that's in question, so I'm going to do just a little simple print statement. Print text, there we go. Text to log out. Why is there a warning sign? So if I click compile, I click run. If you look there, it doesn't print. Huh, what? What's going on? Oh wait, no. Sorry, not print text. Print string is what I meant. Never mind. Okay, so let's delete that. That was for testing anyways. One important thing that we need is our player start. So player start's going to spawn in our player. There we go. Player start now spawned the player. It also possessed the player, but for some reason our actor's not ticking or something. What is going on? Alright, I'm going to do some testing real quick. So add in or find our event tick here. There we go. Print out string. Okay, so the game mode's running. If we click run now, go to full screen here so you can see us. There we go. Debug object right there. And as you can see, there's a little orange line showing the flow of code. So that's very start of the basics of blueprint debugging. But what I want to know right now is why exactly is the base player ticking? Let's look at base player. So we have some controller stuff right there. Actor tick, start with actor tick enabled. Okay. Override input component class. I'm gonna set that just in case. Replication. So this has replicate on, so that's all good. Let's do some testing here. So I select the sphere here and simulate physics. So what this will do, along with enable gravity, is it will cause our sphere to drop. Okay, so that worked. I'm gonna turn this off right now. We're just gonna delete that. Ah, great, my eyes are itching. Why isn't this running? Okay, let's see here. As you can see, there's no orange lines, which indicates that it isn't really doing anything. I'm gonna do something that you should never do. Do a while loop, loop body, loop back to itself. Nope, can't do that. Okay, stick this print statement in here, and then... Okay. There we go. So what this will do is it will detect an infinite loop, and it will ideally cause... Okay. There we go. That's simple. It appears that our event tick isn't running. Because if it was running, it would stop. So let's just make sure that event begin play is working. So I click play. What? Well, this is interesting. Our pawn isn't running, isn't ticking at the start. Okay, let's try it with something else. So I'm gonna map assets. We're gonna just create a testing actor. Test actor. There we go. Alright. So for test actor, let's make it a cube. Okay. There we go. Set that to default scene root. And then event tick print string hello. There you go. Add our test actor into the level. Make sure it's on the ground. If you click Shift F1, you'll release the mouse from the game view, and then you click this little arrow right here. You can then look around. Let me try. So class settings, as you can see, we are using game mode base. That might not be the right one that we want. Game mode base subclass. Okay, let's try. Yeah, okay. I think we want the game mode rather than the game mode base, because the game mode base doesn't necessarily probably start ticking or something for the input. There we go. Okay, that's better. That's what we wanted. All right. Sorry about that. Forgot about that little change. So we're going to delete that testing code like we had before. And then let's go click run. There we go. Okay, now it's not tripping on the infinite loop. Oh, because the condition's false. Okay, so we can delete all that. Click compile. There we go. Click run. Okay, let's see if the input action works. I'm not entirely sure if it will. Alright, yeah, it didn't do anything. Let me look at something real quick. UI enhanced input. Alright, let's see here. I'm looking at the documentation for enhanced input. I need to figure out how to get it working with our pawn here. So there we go. So as you can see, enhanced input action AI fire whatever triggered. That's in the C++ code, and then you have a mapping context, have the modifiers. You can do a custom modifier as well. Triggers. Player mappable input config. Injecting input. Platform settings. We want different. Enhanced input is still relatively new. Oh yeah, sure. It's not experimental anymore. It's not doing anything. If I turn off Android mode. Turn off real-time capture. No, nothing still. Huh. Okay, check project settings. Go back to enhanced input over yonder. Try setting these the same priority, I guess, or something. Input data. We don't have any input data though. Hold on. So default classes, enhanced player input, enhanced input component. So we should be using the enhanced input. Let's see what this tutorial that somebody made is.
What's up, guys?
Yeah. Alright. Sorry about this, guys. Learning as you are. Okay. Oh my god. YouTube, come on. Okay. Camera input, la 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 la, advertisement. Okay. Old input settings. I'm gonna go create the file. Yeah, that's what I did right now. Set up what everything does. Set up the values. Oh, another subscribe button, huh? Skip all that. You can't see this. Okay, in the mapping context. Add the item into the mapping context. Yeah, I did that. And then you add the code. Add input mapping. Ah, that's what I forgot. Aha, okay. So what we're gonna do, let's go to the player controller. No, it's not. Actually, yes, we do. So go to, we're here, go to core, main player controller. Go to the event graph. We're gonna add our first script. So hold on. So let's do, I want it to run on the local machine. Let me switch. So many switches. Switch has authority. Let me check the networking. Hold on. I don't know if there's a macro for what I'm trying to do. I guess there isn't. Okay. Let's just use switch has authority, I guess. What this does is it does that. Sure, what it has authority. Alright, so switch has authority. So when we're running the authority, what we want to do is let's run a custom event. Let's make a custom event. So this is begin play local. So we're going to replicate this to the owning client. Make it reliable. Reliability just ensures the specific priority. And we're going to do begin play local. There we go. All right, so now, let's see here. And get enhanced input local player subsystem. So the subsystem is more of a C++ thing, but it's the way that I guess Unreal Engine 5 has divided its core engine structure up. Before you had to do stuff with the game instance, specifically when we're creating sessions or handling disconnects and whatnot. That we handle the game instance or something like that. Now there's a subsystem for that, which is going to probably simplify quite a bit. So what we're going to do is we're going to add a mapping context. Here we go. All right. Let's add our main input mapping. There we go. And click compile. So now this should run. We're going to do a little bit more debugging here. We're going to toggle breakpoint to make sure that does run. All right. And then just click run. And as you can see, it toggled the breakpoint. So we're going to remove it now because we know that it runs so well. And then resume playing. So there we go. Now we should have the mapping input context added. Ah, the cat jumped up. Hello. So if I look here, here we go. We don't have anything running right now, which is a bit worrying. Ah, here we go. Now it's moving around. Except it's flipped, which is interesting. So I'm right now pressing W and S, and it's going forwards and backwards, but it's on the running axis. So maybe we want to change that. Yes, we do want to change that. So what I'm going to do is, as you can see, we're using this add movement input. This is using a default configuration, which moves it relative to the world. So what I'm going to be doing is overriding this resulting function. Let me see here if I... No, okay, it's not there. All right, so flowing pond movement. Select that. We're gonna go add event for it. No, we're gonna go. Let's see here. Pond commands, pond movement. Add. So, oh boy. Let's see here. On. There's a lot of stuff here. Okay, there you go. What's my cat doing? Oh, my watch is not telling the right time. Okay, that was weird. Cat's weird. It was walking on my arm or something. Alright, so there's a specific function I'm looking for to override that is intended to override the default pawn movement, but I'm not seeing it. That's our enhanced input on component activated and deactivated. Let me check here. Somewhere I think there's, I believe, is a check mark, probably in the flowing pawn movement. 'Cause 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 'c Okay, so looks like we do not have actually such a function to override. So no problem. I'm checking here. Hold on. We'll do something a little interesting. So go to the player here. We're gonna go to blueprints. We're gonna go find that floating pawn movement. Hold on. Oh, I don't see it. Huh. I want to take this. Ah, that might be why, because this is a C++ class. Symbol movement for any pawn class. Consume input vector. Okay, this is sort of what I'm looking for. By the pawn or pawn movement combines a prevent accumulation to control input multiple frames. I'm not seeing it. Okay, I think it might only be something to do with the character movement. Let's set that to none. Okay, so yeah, we won't worry about that. So I'm gonna go here, I'm gonna select this, press C. Now we're gonna add a comment because we want to make sure our code is nice and organized. So this is gonna be basic movement code client side. There we go. All right, and then this here, and we're gonna make it a little more specific. Basic movement input. All right, here we go. Subclass is just character and default pawn automatically handles this input and move. Do some tick movement. So this is using the base pawn class. Here's what I'll do. So floating pawn movement is nice and all for testing. We're not actually going to be using it. So if we actually click compile, as you can see, our input is not working, but if you can look right there, it's still running. So now we're going to implement our custom input. So we're going to do this correctly as well. So right click, we're going to do another custom event. Going to name this move player. There we go. Something to note. We're going to be using uppercase, camel case, whatnot for events and functions. I believe that's just like C++ standard. So move player. You're going to set the replication to run on server. And then important thing, you're going to go to here, the sphere right here. Going to go and make sure that the component replicates. Going to go back to our root actor settings here. We're going to make sure that replicate movement is checked. So doing that should get our player to replicate correctly, assuming our input is correct. All right, so back to here on this add movement input. I'm going to actually make this a bit different here. So I'm going to drag that out. I'm going to make another custom event. Add input. I'm going to do nice and simple, just right there. And then we can just drag the world direction right there. We'll add the world direction. Add this in a comment. Add movement input server side. And then right here, we'll drag out of these. And then we'll do add movement. Nope, not that. Add input. There we go. Right click that, break the link. Drag that there. Drag that there. There we go. So now we're passing the action value into our world direction value. And then the last thing we need to do is run this on the server. Make sure it's reliable so that we get all the inputs in. Alright, there we go. So now we need to move the player itself. So we'll drag that into there. We'll first consume the input vector. And then we'll need to get the actor forward position. So get actor rotation, or get actor forward vector would work as well. There we go. So let's re-add the flowing movement because I'm lazy. So floating pawn movement. Actually, no, we won't do that. So got the forward vector. What I want to do is a basic sort of acceleration, deceleration. So we're going to add some variables now. Just name that acceleration. Actually, no, let's do floating pawn movement because let's do floating pawn movement. We can also see what other types of movements there are. Here we go. So interrupt 2 goes between various points. Projectile movement is like a shooting ball, and then rotating movement rotates around like something or another. Go back to the floating pawn movement. We'll just add that back. And we'll actually change this. So unfortunately, I can't disable its default workings. Let me check here. So it's just a bunch of functions and stuff. Okay, so let's see here. So, alright, we'll just consume. No, we won't consume the input vector. So add an input vector for our floating pawn movement. So this, actually we don't need that. Yeah, no. Hold on, guys. There's somebody's upset on Discord. Yeah, okay. Add every only runs on the source. Hold on. Alright. Back to this. So, alright, so what we're going to be doing actually is getting actor rotation. There we go. And then we want to rotate the vector. So rotate the vector by the rotator. So this essentially multiplies the rotator, which sort of acts as a quaternion or 4D matrix. Multiply that by the 3D vector plus another extra like 1 to get the vector into the orientation of the actor itself. Then we add that. So now hold on. So add movement input vector. Hold on. Consume movement input. That's the function I needed. Sorry about that. What else was there? Get last, get pending. Okay, consume input vector. Drag that in there. There we go. Alright, so now we move the player server side, add the input vector to the pawn movement component, which is running on the server side. It will move the sphere. Sphere is replicated. Sphere will move on the client side. Alright. So now I'm going to comment this. Move player server side. There we go. And then last but not least, we're going to do event tick. I'm going to do a sequence right off the start, just for future's sake. And then every tick, we're going to call the move player function. Move player. Yep, that's it. I'm going to do actually one thing. Is server. There we go. I'm going to make sure that we're running this only on the server. So drag out the is server, and then we'll do true. And move this code up here. There we go. Do another sequence just in case. We want like code to run both on server and client for later. So we're going to comment all this out. Event tick. And then I'll comment out this little subsection right here. Server tick. There we go. Alright. Compile that. There you go. It's saved. And now let's try running it. So go here, click run. So now we have our code running. It's consuming the movement input vector. So now if we apply the vector, yes, it didn't work. That's sort of a bummer. Let's try something. Let's rotate this 90 degrees. So now we're rotated. Okay, so it's still using world-based coordinates. Great. Not quite there yet. Okay, we can close that video. We don't need that anymore. Alright, so let me think here. What's going on with the floating pawn movement? That it is not rotating to match the vector. So, what we could do, let's go print a string here, print some text or string, whatever. Doesn't matter. Just as a debug. So now we can see, interesting. So, all right. Okay, so let's move this actually. So keep that there. Move it up to here at the input, movement input. So we'll add the input relative to the actor rotation on the server side. Now, there we go. Scale value. So we're gonna do this actually a little bit properly here. And normalize this vector. So normalizing just makes it into length of 1. Set that to the direction, and then rotate the vector, then normalize. There we go. Make sure you give yourself enough space to keep things organized. So there we go. Get actor rotation, rotate the vector, normalize, and then we'll get the length, vector length. There we go. Put that into the scale value. Click compile. Okay. So now this should Alright, this should do something a little bit different. And oh boy, now our ball is rolling around. Let's turn off gravity so that doesn't happen again. Let's turn off simulate physics. We don't need physics for this game anyway, so. There you go. As you can see, it's still moving. I think I actually know why. It's not because of our rotate vector. So let's go back to the inputs. I might have made a mistake in main input mapping here. Not the main input, we're using test input mapping. Okay. So W is Y. Okay, huh. Never mind, I thought I messed something up. Apparently I didn't. Alright. So from here, should be able to print out a string here. Print out this value right here so we can see in what direction it's trying to go into. Okay, so looks like our Y input is W and S, okay. And X is, I guess, looks all correct. So that's in within the local. So X plus or minus 1 is moving across the world X plus or minus 1. So X is forward. Alright, so let's look at this here real quick. Because we want to make sure that we get this correct. Whenever you're unsure, you should probably take a step back and look at the sort of work that you're doing. So I'm going to be plugging in the strong pad here. Let's see if this is working. It's not. It's interesting. I don't have my laptop currently out right now. Too much effort to get my laptop out. Alright, I'm going to check in Device Manager what's going on. I'm not sure what's going on. Okay. Interesting. I do have a phone here. Whatever, I'll just use keyboard and mouse. Okay, so put that back. There we go. Okay, we're going to create a new page here. So with our coordinate frame system, there are different types of coordinate frames. So let's say we have like a screen here. First off, we have screen space. There we go. There's our screen space. So this is like Y. This would be X, for instance. And then let's say we have our game object here. Our game object is on this wonderful plane of existence we have here. And let's say our game object is facing X this way. And then we have what is known as the world coordinates. So our world coordinates, let's say X is in that direction. Y is in this direction. And then Z is pointing upwards. Because we're working with Unreal Engine, that's how Unreal Engine works. So like with the ball, then we have local coordinate there. And then we have our Y over here. Why is it just straight? What the heck? That's kind of weird. Okay. So yeah, okay, that's about it. Alright, so what's going on is currently, I use this one. Currently, when we press W, so you know we have W, S, A, and D. So the way we programmed each key is that the W input is X forward. X forward, X backwards is S. Then our Y inputs, there we go, A and D, are left and right. So that's how the keyboard mapping is working. How that's translating into here is translating into the world coordinates. So the X is moving the ball forward and backwards. Or wait, it's the other way around. Is it the other way around? Let me check. So right now, W is about to Y. Okay, so I did that incorrectly on one note. So let me take this eraser, erase it, that, and that. Okay, there we go. So right now, our W is Y. And X is left and right. Here we go. So, we're not actually doing quite what Unreal Engine expects, pretty much. Because Unreal Engine X represents forward. But our forwards is actually in the Y direction right now. So let me check. Let's check. I think what's best to do is check our base player again. So one simple fix actually to do this would be rotate the camera. Nope, not that way. So switch. Currently the camera's in local rotation, so switch it to world rotation. Switch it over the Z axis, 90 degrees that way, and then go into our top view. So you can go down to top view. I'm going to drag it about, let's say here. Make sure it's centered. In order to do that, we need to make sure it's manually centered. So X should be 0. There you go. Let's set this to a nice value like 350. Click compile and see how this looks better. Okay, camera's a little bit angled upwards, so we didn't really check that. Yeah, camera's a bit high, so we'll lower this to about there. I think that should be good. Okay, it's a little too close. Let's move it back a bit. What you could also do is change the field of view, but 90 degrees usually is pretty good, so I'll keep that there. Alright, there we go. That looks almost better. So my A and D are working as expected, but W and S are right now reversed. So why is this? Oh, it's because of the coordinate frame. So if you look in the right bottom left here, as you can see, our Y, positive Y, is pointing backwards behind us. And this is the same relative to this. So our X direction forward is like so. It's to the right, and Y is going backwards. So what I'm going to do, I could either change the input mapping here, but I'm actually going to just do something else. I'm going to manually do it within the pawn. So within the add input direction, I like it to be standard that A is the negative direction. So I'm going to world direction here. We'll just multiply this by a vector. So X, we want to keep that the same. Y, we want to reverse that. So multiply by -1. And Z, we want to keep that the same. Rotate the vector. Click compile. And now it should work fine. Yeah, that's nice. Can now move around. Now, one more thing I want to check is if we rotate this, does it still work? Ah, yes, it does. I'm pressing the directions and it still works as at least I'd expect. Of course, if you want something to be a bit different, then you can, of course, change it yourself as you see fit. Okay, one more thing that we're going to test out before we wrap this up. So to test it out as multiplayer, if you want to check that your replication code works, you want to go down here, play as client. So if I click play, now this is played as assuming I am on the client. So if we check back here on our testing codes, now we have two different base player zeros. So this is what replication does, is it recreates the same game object across the server and the client, and also different clients as well. So we have the server code. The server code is running event tick, and because it's a server, it's running our move player function. The client is not running that because it's not the server. However, if I start moving around, you should see the client lighting up. Okay, the client's not lighting up. Huh, that's weird. No input. Okay. So, this is kind of peculiar. This isn't working. But I believe I have... Let me think here. Okay, so our input's not working. I believe what's happening is that the pawn isn't being possessed, if I were to guess. So let's check if it is being possessed. So there's a nice function on possess. Possess. There we go. Event possessed. You can print out a string here. Just make it like possessed. There we go. And that's just for testing, so I'm not going to really comment it. Okay, so it does possess. I should comment that. Okay, event possessed. There we go. Delete that, delete that. We don't have anything to begin play right now. Okay, I think... Let's go back to the player control. I think there's something wrong with this. I think I know why. Let's go delete that. We change this to what we did in the pawn. So, is server. Break the link. We'll actually make it false. So we want to make sure that if it's on the client, run on owning client if server. And then just for testing, toggle breakpoint. Okay, that's good. So our breakpoint ran. And okay, so we're getting... Alright. So it seems like replication is not in fact working. As you can see, I am pressing the keyboard. We have our input being received onto the server side. As you can see, the server's printing out what's going on. So let me remove this breakpoint because now we know that the client side is sending to the server. But then there's something going on from the server to the client that's not quite working yet. So let's see what's going on. So double check, we got sphere component replication working. Okay, what about floating pawn movement? We might need to replicate that. So let's check that, let's see if that works. Not quite, okay. Actually, not at all. So probably don't need that replicated. Handle the movement from the component on the server. Make sure we have the sphere application movement. Okay. So this add movement input. It applies acceleration during the movement update. Excuse me. Alright, so it seems like the... I check here. Replicated movement. No. Okay. So we're gonna rename this consume input server side. I'm gonna separate this. So I'm just gonna Control X, Control V, make another event. Custom event, there we go. All right, and this would be move player underscore multicast. So now we're going to be doing a multicast. This will run on both the server and the client. I'm going to do that. I'm going to put the vector there, and then we're going to call it from here on the server. So move player multicast. Move player on all client and server. Consume input server side. All right, let's see if that does it. There we go. Uh-oh, what's going on? It's not stopping. That's because the input vector isn't being consumed. So, yeah, okay, I guess we can just, hold on, let me try. Let's go back, delete that. We're gonna go back, put this here. Delete that, and then multicast that. Let's see if this does anything different. Okay, it didn't. Okay, huh. No, because I didn't connect it. Whoops. Yeah, make sure you connect your blueprint codes. Okay, still not. Nothing. Then we will force it up here. So consume the input, and then with the consumed input, move the player. All right, one more little fix. I think I know what to do now. Let's see here. I'll just call this. So this should reset it to 0. On both the server and the client. No, that didn't work. Alright, so yeah, looks like we're gonna need a little bit of work done with the movement. We'll just keep it here. I think this is good progress for now. Save that, there we go. Basic player movement keyboard input. Alright, submit. There we go. Once that's checked in, okay, we're gonna check, not that. We can check here. I'm gonna make sure that we got everything in Taurus SVN that we care about. We got something in default editor.ini. So I'm gonna push that anyways. See previous. Also check the config Android, and also these folders as well. We'll add those too. There we go. All right, there we go. Now we can close out of that. And thank you guys for watching another live stream transition. Okay, not sure why that's not working on my phone. Anyways, hope to see you guys next time. Next week we're going to be sort of working a little bit more with the player. We'll get the player to do a little bit more, and probably start building up a basic testing level. Probably get some of that lighting fixed, because lighting didn't really look too good, in my opinion. I'm gonna unmute the end music here. Actually, we already have music playing. Anyways, yeah, see you guys next time. My phone is nice and toasty. Alright, goodbye.